Welcome, I'm Bill Wake. We're here working on a programming language called Tenth, and we're most of the way through, I think, the implementation of the interpreter for it, sort of like implementing the JVM on a Java system would be. And we're focused today on secondaries calling secondaries. Now, we started testing this, well, it's now 2 weeks ago because I was on vacation last week, or at least out of town. And we hit some problems doing it. And the next morning I took a shower, and in the middle of the shower, it's like, oh, I think I know what's wrong. So I withheld and did not try and test it out or anything, but we'll see if my insight or my guess is on track. Welcome, Mudshark666. All right. So the problem we were having is it felt like we needed more indirection to get to the secondaries. And I think the problem is in the test, not the, well, the code's screwed up now too, but in the test, we're building, let's space these out a little better. We're building, well, first we get the addresses of the various headers, and then we build a dictionary with them in it. And then here we are, we're building secondary 1. We're calling 0 as start 2D header, and I'm just, oops, I think a little bit of comment will help. Interesting, the numbers are a little taller. Or mates with slashes. Okay. So this secondary says call start header, call secondary 2, call secondary end header. And the secondary 2 says call start header, call push, here's my data 55, and then call end header. I think the issue is this is wrong. I think this needs to be the actual address of secondary 2. And so what I want to do, well, I'll tell you what, I'll take a snapshot of this. I think it's a little bit right. Like this maybe is correct. We need to get X20 loaded up for any individual method. But this stuff, there's too much there. So I'm going to revert this interpreter. Okay, did I take a picture? Is that this? Yeah, okay. And let's revert this file. Did we do anything else in here? Maybe I'll diff it first. Not quite sure what we did. Okay, yeah, that's deleted comments. Okay, no harm there. And then change this all over the place. Okay. Let's revert that one then. Discard changes. Yes. Okay. It's always traumatic to revert something, but it's almost always seems to be the right way to go for me. Okay. Let's close this. All right. So first we got to fix our tests. Now we're going to look at secondary add. He's not going to be right, correct? Because he's got 2, which is an index off this one multiplied by 8 or something like that. Let's go find that macro. Interpreter. Is it an assembler macro? Or is it in this file? Nope. Okay. It must be this. No, it can't be one of those. Load address. Oh, am I going to regret this now? Oh dear. Core tests, interpreter tests. Oh, here it is. Core tests.macros. Okay. Yeah, so this thing has to get the index and multiply and all that stuff. I think we want to just get the label. Yeah, you're right. Core test macros. We're going to get the label. So I think we need a new macro. Okay, so it's secondary, I don't know, address routine. Label. I think address is probably the most accurate. Stores address at x0. I don't know if we updated or not. Parameter is secondary label. And it's the and uses something. Macro secondary address with secondary label and macro. Okay. So feels a little misplaced maybe, but okay. Interpreter tests. Okay, it's our last test. All right. So here, I want to say secondary address. And then really, I want to say else secondary to, I think. Where is else secondary to? Okay, it's here. It's going to get filled. Yeah, first word is start 2D, and then the rest. Okay. Good. Okay, now how do we load this? Okay. I guess core tests is okay. It's a macro. It's across the whole system. Okay, so we need to. Well, this is really just like a load address. Yeah, I think it's like this. X here points to secondary, but will be updated. Okay. Okay, so if we load the address, we load x0 with the address, and then we're going to have to store x0 in, well, x3 points to the secondary won't change. X0 is sort of the current cell. So x3 is already this, so we don't have to load it again. Okay. Store, I guess it's really x3 in x0 plus post increment 8. Sound right? X3, because you've already called secondary start, we're holding x3 around, and uses x3, updates x0 is probably the way to say this. X3 is the secondary label. Oh, wait a minute. That's the label of the one we're sitting in. Okay. So I think I do need to load not that, but not this. We'll just use x2. Load address x2 with secondary label. Okay, so he's loading the address of the other routine to call, and then we're going to store x2, uses x2, updates x0. Okay, so we load it. That's the other thing we're going to call. We store that loaded address at the current program, or sort of the not really the program counter. What would you call it? Just sort of like the next instruction counter. Okay, and then there. All right, so I think that's closer to right. And so this secondary 2, yeah, I think that is better. Okay, now interpreter, what's he gonna do? Well, this is where I want to look at my picture. We did x20 gets x0 plus 8, assuming that x0 points to our body. Okay. Let's see how this fails. It certainly should fail. Ooh. Do I have this stuff in here? Oh, I was doing something else. Well, make is good. If I saved everything. Wow, starting out slow here. All right. Okay, secondary calls another secondary. Get an error, bus error 10, interpreter test.out. Let's look at interpreter tests. Interpreter tests.out. Okay. So I want to find our secondaries. Kind of amazing how big these get so quickly. Okay, interpret empty program, no. Secondaries run. Secondary calls a secondary. Okay, so this stuff is the string. That's not relevant to us. Enter P, X0, secondary calls another secondary plus that. Okay. It's unfortunate they don't link across they just link across the first name. Okay, I can't quite tell. 416. Well, there's my 55. Well, I'm going to work on the assumption that it's starting out okay. I hope we have the test right now, but I know we need to do this change. So we need to, I guess, add x20 gets x0 plus 8. Okay, so this is skip over. Oh, well, it's start VPC just past start 2D call. Okay, so how does the interpreter know it needs to change the VPC to that loaded address? Yeah, so I think, well, let's make sure the run interpreter is doing the same thing. Yeah, so move x20 to x0. So in this case, x0 is the starting address here. So let's go back to our test. Hopefully, yeah, we've loaded x0 with secondary 1 and we call run interpreter. So that takes this and moves it to the virtual PC. I don't know if we may have another level of calling than we need, but we're going to start 2D with this, well, with that in x0, but we're skipping over that address. So I think I think this will work out right. It may be possible to optimize it somewhat. Okay. So I think that's okay, but now here, X, maybe this is your question. I think it knows it should change it because we're going to start interpreting a new secondary. So we have to be pointing at the stuff for that secondary. Now we've conveniently saved X20 away. So when we finish with this one, whoever picks up will still have X20 pointing to their partway through. Okay, but here we don't have X0 set. And I think that's the part we probably did okay with. LDR X0 is X20 plus 8. Okay, so yeah, that's getting to whatever it points to. LDR, oh, X0, well, X1. Okay, I'm going to take a peek over here. Everything else passed, so at least something is on track. Okay, so I think that's a good sign that core tests pass. All right, so add X20 and then increment by 8. I think that should be X0. Because contents of X20, well, X20 is pointing to the word. The contents of that are an address of the block that word is at. So I believe this should be X0. And then the block of that word we have to load because that's the starting header is that routine. And then we'll load that next one as a temp and then this. So I believe this will give us X0 pointing to the block of the next secondary we're calling from this one. And then loading the address at that block gives us the routine that's going to interpret that method. Okay. Or the address to call on that method. Okay. And let's do this again. Okay. Different error. Bus error. Okay. All right. I guess I'm... I gotta show the code and do the math, I guess. There's no way around it. Okay. This is interpreter test.out. Okay, so let's... Now, can I see anything? Does bus error 10... Well, I don't remember what that is. Actually, it's probably Mac OS. I'm not sure syscall Macs are standardized. Well, they're standardized to something different. Yeah, I should search Mac OS. It's not error. Memory allocation error. Well... Really, I was hoping for more of a reference material. What's best error 10? Okay, sig bus, yeah. Usually it's accessing, okay, yeah, exit bad pointer. Okay. Oh, yeah. All right, I'm gonna have to remember how to run this debugger. Okay. I assume we were running this last. L interpreter. Loop. L interpreter 100. Where that came from. Oh, I can't do that. Okay, let's break on start 2D. L labels get stripped out. No. Oh, minus B. Okay. So I want to come here. Well, I guess it's that second instruction. Okay, it's going to push us on the stack a little bit. It's going to be a little, I don't know, that's a little disconcerting, but all right. So I think if we run, well, I want to break on the test more than I want to break on the other. Okay, so now if I run, I'm gonna skip forward to that test. Secondary calls another secondary. Okay, good. PL print. So secondary calls another secondary. Okay, yeah, print. We got to skip over some stuff. So I'm just going to continue. And we should stop at run interpreter. Okay. All right, now let's reg read x0. Debug data plus 80. Okay, now I'm pushed the routine. You know what to do with the next value. Yes. I mean, that's what the jump instruction, I'm sorry, that's what the procedure call of this thing should do is take the next value and call it. So, let's see, where's the best place to look at? I guess this. So it's going to have the start 2D routine. It's going to see the address of L secondary 2, or what I want it to do. It should see this address, and this is the next thing in this data structure. So this is first the bytes for start 2D, then the bytes for the address of the secondary, and then the address for N2D. So when it goes in here, like we go in there the first time, it's going to actually call itself and then go in here, I think. And maybe, again, it's easy to get off a level. Need a jumper subroutine. So the virtual PC will be tracking this. Let's see, where is that going to be? Interpreter. All right, so here, this is going to point to secondary 2's address, and it should load the contents of that address. So it's following the pointer here, should take it to the address for secondary 2 is in X0, and then it's going to load whatever's in that address, because the first word is always the address of a routine, and then call that through and then branch around. So that's intended to do that. If it worked, I'd have a better argument, I recognize. Okay, now this data, debug data plus 80, how do we get that map before? I've totally forgotten. Oh, maybe we just did the memory thing. Help mem read. Okay. Read debug data. Okay, and I guess I want to do count minus B. Memory will say it as binary. No, we don't really need binary. I guess maybe it's just minus C. Memory minus T name. What's minus T? No, we don't need a type. Okay, memread address. Oh, we got all these things. Okay. Memread minus C count minus B. We don't need binary. We don't need force. Am I not doing this right? Mem read minus C count address, I guess. Okay. Now, is 80 X0 points to debug data plus 80. C240 address is what you use. Yeah. Okay, so 4150 is debug data plus 80. Okay. Well, this is 16s, right? So 1, 2, 3, 4, 5 is not very promising. Okay, so I'm not clear that our data is set up right. Debug data. I don't even know what that is. I think I want to say debug data. Oh, that's here. Okay. So that's my test dictionary. 10 words. Maybe 16 would be a better choice. Yeah, it looks way too empty. And this is 1003D90. 3F58. I mean, that all seems like it's further back. We don't really need those dictionaries. Okay, maybe test. Maybe this is the best place to start. All right, let's run this again. Yes. Okay, so we're here. I guess at the point we call run interpreter. Well, here's this. Pass the secondary to the interpreter. L secondary 1. Okay, so I guess at this point we should see the data we want, but I'm not sure we're doing this part right to get there. Okay, so interpreter, run interpreter. Okay, he's going to create the data stack. He's going to load the virtual PC with this. I don't know, the stores and loads seem, I mean, it seems like we could just do this, and branch to start 2D ourselves. Okay. But I guess at the point of, let's break at run interpreter and validate our data. Okay, so break set -b run interpreter and run. Yes. Well, I guess I could have continued. All right, continue. All right, run interpreter. So now let's look at X0. Debug data plus 80. Mem read minus C240 debug data. Again, very empty. Okay, so what's that back there? Well, okay, I'm gonna break it again. All right, we're at the top here. I'm gonna step. Is that S? I can't even remember anymore. Yeah, I'm getting around that. LDB. Step in. Yeah, I think I can just say step. This is all getting us through that string length. Is that going to do anything? 300? No. Oh, I shouldn't have done that. Okay. I'm in string length already. Okay, sorry, I gotta do it again a bit more efficiently. Okay, this is fine. It's a load. That's a load. But I think I want to do next instruction. Is that the step over? Yeah. Okay, we're back in there. And now I'm going to branch forward past all the text. Okay, that no op ended one of our macros. Probably not needed. Okay, so where are we? In our code. I think we're... All that printing and stuff, that was the test frameworky stuff. I think the no op is right in front of this load address. Okay, so X00, well, that doesn't look right at all. Oh, they're killing me with this stuff. Netaddress P, X0 is start 2D. Is that just not right? Oh, it's 2 steps. Okay, okay. A load address turns into 2 instructions. One gets the offset and one gets the page number. So All right, so we're going to skip over those two. Okay, now add x0. I guess we're looking for the store x0, x1. Okay, reg read x0, reg read x1. Okay, start2D header, that's promising. All right, so we want start2D header in x1 and start2D in x0. Okay, so we're trying to write this 3D90. Okay, let's get the latest version here. 3D90 is start2D. Okay, so the start2D address should go in the start2D header. Okay, let's step, and then mem read -C20 start2D header. Oh dear. So that's backwards, isn't it? X0 is where we're putting it? No, 41F0 is where we're putting it. Okay, so I'm reading the wrong thing. Well, I'm kind of not getting it. So start2D header. This is the address of start2D header. Okay, that's more promising. All right, so 01003D90 should be the address of start2D, and it is. Okay, so the first word, okay, so start2D header now contains a data area address of a code area thing. And that's the thing that drives me crazy, because every assembler I've used lets you create a reference to a code location in a data place, but this one makes it hard. Okay, so I think we've done that step correctly. So excuse me. So I'm inclined to kind of trust these three headers as being right. So I'm going to skip forward through those. The store is kind of the critical one. That was 2. And now 3CD4. Three C B D 3CD4. Oh, there it is. Okay. That's the address P. Okay. So I think that's the second one. Oh, it's so buried. Three C94. 3C94. Okay. That's that one. I think this is the third one. Okay, so I'm going to step a few more. N2D. Does that seem right? N2D header. Okay. Okay, at this point, where's my mem read? I believe our memory should be set up right. So mem read minus C240 blocks, start 2D header. Got the wrong one again. What did I do? Do I have history? Yes, good. Let's take this one. Well, I'm going to read 240 just so we get enough to see everything. Okay, so we should have 3 words of addresses. 3D90, I believe it's start 2D. Yep. 3F58 is push, I think. Push. And then 3D AC. That should be N2D. And it is. Okay. So for our 10 minutes of work, we know that the first 3 words are what we expect, or at least I think they're what I expected. All right. So I believe that much is correct. Now, I thought we'd walked through all this before, and it was what we expected, but maybe this else oh. That's not going to be wanted. I don't think it's going to hurt anything because we never reference it. Okay. So dict add is going to be in core macros, I think. Yeah. So it's a load address, which is 2 instructions, a store x1, x0, pound 8. Okay. So I'm going to say we're going to see 4 of those. Okay. Load address, 3CA8. 3C6, 3CA8. Okay. So that should be the end of our 3 loads. Then we're populating the dictionary. 1, 2, 3, 4, 5. 1, 2, 3. Okay, that must be the header. Okay. I'm going to try and set a break at store. Well, I'm trying to figure out where this dictionary is. Entropy add store. Entropy add store. Entropy add store. All right, let's break here. Okay. I don't know if it's faster for me to just put a label in. This address is not secondary 1. Yeah, I really want to break here. Unfortunately, I don't think that's going to work. hell? I think there's a list or a show. Yeah, break list. Start 2D, secondary calls another secondary, run interpreter. Break, delete. Okay, because they complained it didn't work. So, all right. So I'm going to continue. No, I don't think. Oh, there. Maybe so. Good point. No, still doesn't like it. Okay. I'm going to break. I'm going to run till that next call to run interpreter. So we're at the start of run interpreter, and now we should be able to look at our memory and decide if it's correct. I mean, all right. So start 2D header, that should be okay. So let's mem read minus C240 start 2D header underscore header. Okay, now I keep doing that and it keeps looking wrong. Start 2D header, how is that not? Well, that's a quad. Load address x0 is the value we're saving. So that should store x0 start 2D into start 2D header. And it seemed like it had before. Pass fail. This is not like we're... Wow, debugging assembly code is so annoying. Newsflash. All right. I mean, I felt at this point 41F0. Okay, let's do the hex. No. Okay, so where that is relative to anything. Okay, those headers look right. Okay, I don't know why that doesn't look like start 2D header. But okay, now I want to find test dictionary. Well, that should be debug data. Which appears to be... Well, let's see. How can I show? That's certainly a good question. There's a stack or display? No. Frame. I don't know what memory frame is going to do. Okay, so we're at run interpreter. Current stack frame, diagnose. Thread backtrace. I want to see my stack. Yes, I definitely can. 5 ought to do it. Okay, so I take that to be, yeah, we're at secondary calls another secondary. 3D58. Close to the top. No. 3D. 3D58. All right, so I mean, I take that to be that we're in secondary calls another secondary, so I'm pretty sure that part's okay. Now, and I'm pretty sure. Well, I'm pretty sure I don't know what's going on here. Because I would have thought debug data would be our test dictionary. So it's like we loaded them into the wrong place. I think what's the easy way? Excuse me. Well, I know what I can do, right? I can. Oh, we're only calling this. Okay, so I haven't commented them out, but they're not being called. So that seems okay. Am I just confused about how store works? I mean, we've done stores before, but I mean, I can look that up. STR. Yeah, instruction set is a bad word to use. It's like 160 is our stuff. Load store register. Okay. STR. Register offset. Okay. Store XT in XN. Okay. XT is the name to be transferred. Okay. XN is the register. Calculates an address from a base register and offset and stores a value from a register. Applies when size equals 11. Okay. Store XT. That doesn't help. Share decode t equals t. Address equals xn. So that's the address we're writing it to. We add the offset data xt, and then we write it into the address. So did you use a register that was needed in the secondary access macro? Well, maybe. Yeah, let's go look at that. That's a core macro, I think. Some are macros. Load address. Okay, so we only use the register you mentioned. Okay, so there's not really an issue there. We load that address into start2d. X0 has start2d. Well, I mean, something is going right because, I mean, maybe it's in the wrong place, but it seems like the address for start2d, the address for push, and the address for end2d all end up where they end up in a sequential block of memory. Now it happens to start where I don't expect it, so that's kind of disappointing. Okay. Debug data. I would have thought this created 30 words of stuff. Oh, maybe I'm not showing enough. That looks pretty zeroed. Debug data. I mean, I would expect 80 words, 80 bytes rather, 240 bytes to be that, and then the start2d header. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is 80. 1, 2, 3, 4, 5, 6. Oh, that should be this, I think. Store x0 in the value of x1. Okay, I'm going to run to here again. I don't know. Yeah, I'm just going to rerun. I'm sorry, I do that a lot, but I got to make sure I'm where I want to be. Okay, so we're going to step, next, step. Okay, that puts us at our code for these. There are 2 addresses each, or 2 words each, 2 instructions each. So there should be 4 of those followed by a store. Okay, so step 2, 3, 4. Now let's look at x0. And x1. (41F0) is start2d header. And the memory stuff we looked at, well, 41F0 is start2d header. Why is debug data showing up there? Are these not? We've done that sort of thing before, I think. Oh, maybe not. Could it have not allocated these? I mean, this start2d header is 41F0, and it knows it. Okay, so it should write. Okay, that's 0 for now. But the memory we want to look at is going to be above it. All right, so I step and I read that again, and it's there. Assuming, I mean, and that's where it thinks start2d header is. And yet it somehow thinks debug data is there too. I think. Let's bang 46. Debug data fails for 0. Okay, so what's going through my mind is, I don't know, debug data seems like it's pointing to, we're in the data segment, we're aligning on 8s. The fill should be 10 words of 8 bytes each, I think. Let's find our assembler write-up. Fill, repeat, size, value. Well, let's put 2, 5, 5, 3. I don't. I also think I'm guilty of changing things and not running make again. Okay. Well. Do it here. Okay. And I'll run. Okay. Step, step, next. Step, step, next. Step, step. Okay, that puts us there. All right. Let's redump this. Okay. Mem read -c 480 debug data. Memory read failed. Failed. Maybe it's not accessing this segment until step, 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 step. Reg read x0, reg read x1. Okay. Mem read. Is it not big enough? What? Okay, x0, x1, if I step, okay, and it's there. This is not, okay. Let's read x0, read x1. Start to D header seems like it should be at 41F0, but when you read there, it never gets there. I'm puzzled for sure. Okay. So we've stored our first thing at what appears to be start 2D header. I'm a little puzzled by this, though. I don't know how I get the contents of a name. Ugh. Variables we don't have. So it's raw. I've not seen anything. Okay. Let me just continue. Okay. Bad access. Address equals 4100. Which is debug data. Okay. I got to change up something, right? Let's run these other two tests, then. They should, if they're not passing, we know something's wrong. Okay, so maybe we've screwed up something else completely, and this is just not even in the ballpark. Okay, those do pass. All right, now, I don't remember obj dump enough. There was a way to dump the symbol table. D is executable. File headers. Minus S. Okay, there's some section data. Section text, I don't care about. That's our code. Here's data. Well, there's our 41. F0. Oh, there's my fills. I put 2. I guess that's one word. $4,100. Okay. So those words get in there. All right, I'm gonna DDD1. Well, DD1. SS1. And SS2. Okay. I hope that can get to it. But, oh, in that dump, though, right? It's pretty big. 1, 2, 3, 4, well, 4, 8, 12, 16, 20. Is that 20 bytes? Or 80 bytes? It's more than I expected. I guess that's what I'm getting at. Fill 10 words, 10 copies of 8 bytes containing the number 2. Now, 2 digits make up a byte, right? 1, 2, 3, 4 bytes, 8 bytes. Okay, so one of these is 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. 10 times that's 80, so 240. Okay. All right. I've renamed these labels. I've only got this one running. Let's do a make clean. And a make. And then bang LL. So 41F0 should be, yeah, was that? That is puzzling, isn't it? Oh no, it's down, it's not quite the end. Okay, so this should be 1, 2, 3. So that should be these 3, well, 3 entries, I guess you'd say. One block, that's 4 bytes or half a word. That's a whole 64-bit word. Okay, and they're coming right after the 5, so there shouldn't be any issue there. But it looks like 4100 should be the start of where we're going to. So let's break set this. Okay, I'll run. Okay, let's try this. Memread minus C240, well, 480. And then this address here, 4100. 5F104. Okay, I guess I need the OX. That's better. Okay, that's looking good. There's my 2s. They're going to get overwritten. 5. There's 41F0. Okay, now let's do a memread minus C 480. And then I want this to be my new DD1. Oh, it doesn't know the variables. Okay. Yeah, 41F0 is here, and 4100 is here. Okay, so now if I break set minus B, run interpreter. Okay, that should get us to where the data is run. Nope. Continue. Okay. So here's run interpreter. Now let's look at this data again. I'm going to get this line. Okay. What are we seeing? Okay, there's our O2s. So we didn't write down very far, just 4 words. Here's a 4E100 reference. That's the header. Is that right? Okay. And then 41F0, that's the thing we've checked. We believe that's that's there. Okay, do you need quotes? Oh, maybe. I didn't before though, but I always had these weird things. Mem read -C 480 DD1. Oh, single. Well, I've gone and picked a name that's octal. Oh, I didn't make them globals. Ugh. Is that going to matter? I don't think that matters. Yeah, I don't know. Like I said, I picked poorly because I picked one that has all hex digits in it. All right, but I think we believe we're looking at the right place here. A, B, A, B. What do you have to do with A and B when you're totally different? Oh, 41 is A. 4 times 16 plus 1 is 65, which is A in ASCII. Okay. F is a high bit, so it's not anything. All right, so we're at run interpreter, and we believe DD1 is here. Now, 41F0, 41F8. I feel like I've got another indirection level wrong or something. So test dictionary should be, is he start 2D header? Okay. The dictionary should have addresses of code routines, right? So this should be the contents of start 2D header, not the body of it. So I think we've got these header values right, but I think the dictionary needs to, I think it needs to put the contents of them. Yeah. Tell you what, let's take a break, 3 or 4 minutes, come back, see if we can straighten out what these things are pointing at and go from there. All right, welcome back. Well, what I've done is I've gone and pulled up one of our slides. This is sort of the classic way that the fourth interpreters would do, is they'd have this dictionary of entries for each primary and each secondary, but for the primaries, you'd have the name of the routine, a link to the previous dictionary record, the address of the code, and the code will be right there following, and then the code is normal code and it ends with return or a branch, but that's not relevant to us. Now, what I've done with with our dictionary, I mean, I call it a dictionary. It's not really much of a dictionary. I've stripped out the name of the routine, the link, and the code. So the code in our case is sitting out there somewhere, and code 1, 2, 3, and then what's left of the dictionary is just these addresses. So the code, normally the code would live immediately after the address and point to it. In our case, we're just putting it somewhere else and pointing to it. It shouldn't conceptually matter, but I think the big thing is, though, that code 1 is an address in the text segment, the actual code part of things. Oh, this should be a 2. And same for code 2, code 3. They're all text sections. This structure is in the data segment, but the addresses it contains should be things in the code segment. Okay, and so when I look here, what I see is 41F0 is an address in the data segment, not the code segment. So I'm pointing to the address. It's like I've got an extra level of indirection. I think what we need to do is put this number, at some point we need to load this number in to here instead of this one. Okay, so this is 41F8. That's that. So that's the push, and then the 3D AC is the N2D. So those are the entries we've got. I'm puzzled, though. Maybe we never used dictionary start before. We didn't. Okay. I think when you point to secondary 2, you point to the data. Yeah, that's right. The secondary will be it won't be, where will it be? There will be a dictionary that contains, I mean, we somewhere have to have the names so we can get to the routines and stuff, but that dictionary is going to live in the data segment, and then the secondary is also in the data segment, and this will point to the data segment in that case. Now, I don't know what we got here. We're pointing to the data segment a lot, but this is F1, right? Secondary 1. So we pointed to start 2D. We pointed to 41F8, which I think was push, right? We did second. Yeah, I'm puzzled. Secondary 2. Well, oh no, I have that there. Well, I guess that's kind of okay. We don't need it. It shouldn't be there, but I don't think it affects this. But I do find it weird. 41F8. I mean, I would think this should be start 2D, the secondary, and then end 2D. And then the secondary should be, oh wait, what have we got? No, that's the dictionary. So it should be, okay, the third entry should be the one. 41A0. 41A0 is here. 4100 is the address of this, is the address of start 2D. 4108 is the address of push. Okay, so this is start 2D push, or no. Start 2D push, secondary, and header. 41, 4200. Oh, maybe they read backwards. 4200 is here. Well, that can't be right. Well, I shouldn't say can't. All right. When you get to secondary 2, you point to the data. That's good. Yeah. Okay. So I think my dictionary is built wrong. I think this should be the contents of 41F0, which is the actual code address. So we're building this thing in stages because, like I said, I can't put relocatable addresses in the data segment as far as I can tell. And I've tried several ways, including a couple offline. I don't think I have a way to do that. So I have to load the data into somewhere in memory. And now I have it, I can copy it in. And I think this needs to do that. I think, okay. So I don't think this is pushing the contents of the routine. It's pushing the address of the pointer to the contents of the routine. Now, maybe that was because I was mixed up about the levels or something earlier, but I think I'm clear that should not be that. It should have taken the contents of start2d header, not the value of start2d header. Okay, so we load the address of start2d header, not the contents. Okay, 41 is where the start2d is stored. 41F0 is where that's where the code address for start2d is there. So I think what this is needing is another layer of indirection. Like it should be load x1 gets contents of x1. Okay, so that gives you the actual address of the routine, and then we store that address at the position in the dictionary. Okay, I believe that's what that is. All right, now we have dictionary start. Now I don't think, okay, let's get this kind of right. Oh, that's the screenshot, that won't work. All right, interpreter test. Let's get this right too. This should not be here. N2D should be N2D should be 2. So slot 3 should be slot 2 and here. Okay. Right. So when we repeat that, I expect this will give us the address as we want. Now, this secondary 1, well, we'll see it because of all the 3s. All right. Okay. So here we are. This is still getting the test. Yeah. Secondary was, yes. Yeah, that's the real thing. We got to make that they're supposed to be symmetrical. Let's see, I have a picture for that too somewhere. Way early. Yeah. So primaries and secondaries look the same in terms of the original dictionary structure. Both have the name of the routine, the link to the previous, the address of something. In the assembly case, it's got the address of the code to call for the primary. Here it's got the address of the code to call that start2d routine that's going to interpret this list of addresses. And so each of the things that it calls is going to either be a primary with an address or a secondary with start2d. So, okay. Let's quit this. Yes. All right, do a make. So tired of, okay. Well, now let's go see our stuff again. Oh, if 0 does not pass jump. Did that pass before, or did I just ignore it? Oh, that had an error too. Okay. I don't know if I get back to another one. Tracing this stuff is so obnoxious. Is there, oh, that's been failing all day. Okay. I probably knew that before my trip, but did not realize it now. Okay, well, that's interesting too. So we got to make sure that works as well. All right, but I think, all right, so we'll run this. Now, we dumped our data segment up here. Data. I imagine it's the same area. There's 4100. Okay. So break set minus B, run interpreter. Okay. Mem read minus C 480 OX. That. Now this may not, oh no, it's okay. Yeah, I don't care about that. Okay, there's our 2s, our 3s, our 5s, and there's the dictionary stuff waiting to be filled in. Okay. Now I'd probably be better off with like -1, -3, -5 or something to show me where things are, but I think this is okay. Let's make it happy. Okay. Break list. Run interpreter. Okay, so I'm going to run, and then we're going to look at that memory. And it should look better, if not perfect. Okay. 3D90. Better be start 2D. Start 2D. Okay, so we got the start 2D routine in there. This is the dictionary. 3F58 should be push. I think that's the same number as before. Yep. And 3DAC should be N2D, which is what it was before. 3DAC. N2D. Okay. So I think we've made forward progress. This is our list of code addresses. Now they're put into the dictionary, so they point to the routines they should. Okay. Yeah, I'm sure I screwed myself up somewhere. All right. So that, well, it's really the first 3 words. That's the dictionary. Now the dictionary points to all code addresses, which it should. All right, now we get the primary, or sorry, the secondary. The first one, okay, they're off a level 2. Okay. 4100. He should be, he's a level off as well, I think. I think he needs to store the pointer here should be the pointer to start 2D, not to the pointer of the address of start 2D. So the secondaries have kind of the same problem. So 4100 is this, which is start 2D. Then it should have a push 41A0, which is down here. Okay, but that seems good or better. Okay, so 41A0, this one's pointing into the dictionary, which it should go 1 level deeper. This one's pointing to the other secondary, which starts with N2D, but again, it's not quite at the right depth. Then it does a push. Then it has 55. 3 times 16 is 48, plus 7 is 55. Then it has an N2D, 4110 is AC3D. Okay, so yeah, our secondaries are also not going deep enough. Wow. It's nice for the test. But okay, so secondary add. Let's go look at that. Okay. So I think the solution is the same kind of thing. We're going to load a register X2 with the contents of X2. So we get down, basically, this is what we're doing. The way I think of this, I should say, is I'm thinking of this as kind of the compile step. And so the compiler is kind of filling in the slots in the secondary. In the longer run, that'll be done by the actual compiler, but we're sort of acting like a compiler here to populate these instructions just like the compiler would. And that's why I kind of make the JVM analogy. The code we're writing is JVM code, and so we're kind of faking how do you write JVM code, except it's not JVM. And then the compiler normally would convert our source code into JVM code. Well, this part's acting like the compiler, okay, or would be if I hadn't screwed them up, okay. But now I think that'll do that. Secondary address, that seemed to be doing right. Secondary skip just moves past it. Secondary target stores address of a secondary cell. I don't know what that is. Is anybody using that now? Yes. Oh, that's our ifs. Okay, then we'll come back to that one. All right, but they may be off too. All right. So we'll rebuild again. At least we're making progress a little bit. Okay. Yes, make. Oh, but not enough. Okay. LL. Okay, break, set. Here. Okay. And let's just redo this just to make sure we're current with it. That's the text segment. 4100. Yeah, there we are. Okay, so those addresses haven't changed. Good. All right, so I break there, and then I'm going to break at run interpreter. Run. Continue. Okay, so we're where we were, and then we did mem, read, I forget the number, minus C316, OX, this. Okay, so now dictionary still has pointers to the code segment, twos after it to fill it. This is secondary 1. Oh, still not right. $4,100 is the address of that. What happened? Secondary address. Secondary add. Okay, so secondary add 0. takes that. 8 times 0 is 0 plus x1 and where x2 is that. What is x1? Next one's the dictionary. Okay, so dictionary plus 0 is the address of the thing in the dictionary we're looking for. And we're going to load x2. I'm just reusing the register with the contents of x2. So the contents of all right. X2 is not correct. So I think that's the instruction I just added, the LDR. So let's say it uses x2 as temp, reads x0, x1. Okay. Whoops. Reads x1, adjusts increments x0. Okay, so x1 is the address. We loaded it in. We're adding stuff to it to get x2. That should give us the slot in the dictionary. Excuse me. I think we do want to do this though. We want to take that slot, read its contents, which is a code pointer, and store the code pointer in our secondary. Okay. Let me I don't know why I'm not trusting that we I'm not 100% convinced we've got the dependency on the macro and stuff right. So that's why I'm making again. All right, but it didn't pass, so that's a bad sign. All right. Break set minus B. Run interpreter. We'll run. Mem read. Yeah, something's wrong. Okay. Oh, this is looking better. I must have not. I'll have to double check that. All right. So that's our dictionary. That looks good. This 3 sections. Now it has a code address. That's start2D is 3D94. 41A0 is the secondary down here, which it should be. And then 3DB0. Let's make sure that's, I think that's changed. Sorry, 3DB0, 3A, 3C, 3DB0, N2. Okay, that's the N2 address. All right, so this has start2D, secondary, and 2D. This one has start2D, 3F58 is push, data value, and then N2D. Okay. I think this is what I want in the structures, because secondary should be a mix. Everybody should point to a code header. All right. Now this threes. A0 41A0 here is the header of this block is the start2D routine, which is right, followed by a list of addresses to interpret, some of which are pointers to data, some of which are pointers to code. But the start2D and 2D routine well, okay. Yeah, N2D just jumps right into doing its job. There's no other level of addresses or anything. Okay, yeah, so I think that's okay. Wow. Now I think the data is the way I think it should be. Whether I'm right or wrong, that's another question. My record today is not so good, but I think that's everybody's got a pointer to an actual code segment, text segment address, or a data segment address, and I think they're each pointing to the right ones. Now, the place now we're in run interpret. Okay. Interpreter. Okay, so he's going to set up the data stack, and he's going to set up the virtual program counter. I don't think he needs to do that because nothing's going to happen to it, but okay. He's setting up, X0 already points to the word address, okay, which is the beginning of our code block. I still have address since that one points to data. No, I think that one is correct because, let's see if I got a picture that would help. No. I don't know if I have a secondary calling secondary picture. But the way we're building it though, this is a list. It's a list of stuff, and it's the address we're getting is the address of, well, it's really like pointing here. This would be called the word address. This value here. So when we talk about a secondary, we should be pointing to a block of data that has a word pointing to code, always into a code address of some sort in the text segment, followed by other primaries and secondaries, which could be more data entries, or it could be text entries, fixed code. Okay, so I would expect this to be a mix. Now, I may be, I may be wrong in my assumptions, but like if I think of running this as like at the sort of the REPL, command level, somebody types something in, and those things they type in have to get stuck somewhere. Well, we can't put them in a code segment because that's a fixed thing. You're not extending at runtime without a bunch more effort. It's just going to be a data segment chunk. We're going to write it in the next entry in the dictionary, make that list, and it's going to be fine. So I think that part is okay. Again, I don't know if I have a picture. Did I do this? No. Huh. Secondary 1 pointed to secondary 2 dictionary entry. Yeah, I'm not sure this is. Yeah, well, it sort of is. It sort of ignores the header stuff, but and what's the last piece? Okay, dictionary start push. I think this dictionary picture is wrong though. Sec2 is not in the dictionary, so I don't think. I think what I had reflected that, but it's not how it really should be. Okay. We're at the point, we're at the interpreter, and we've got the data structure the way I think it should be. I think there's something going on. I mean, we know it fails because the test failed, so something's wrong. But I think we're to the point where the test may be correct and the code is wrong, which is kind of where we wanted to be a long time ago. All right. Now, so run interpreter. Okay, well, I guess I need that code up there. It's going to push on the stack. It's going to create the data pointer. It's going to create the virtual PC kind of unnecessarily, I suspect, and then jump in. Okay, so let's just break set -b start to D. Okay, that's there. Okay, so I'm going to do that and continue. Okay, now when we come in here, breakpoint. Okay, good. We're ready to store all this stuff, but x0 should point to the start 2D of a secondary in our case. We're trying to execute secondary 1. Let's make sure I said that. Yes. Load address x0 secondary 1. Okay. So x0 should be, well, x20 is the starting point of the list. Yes. True. Not true. x20, the way we are now, is the pointer to the start of the secondary, which is the start 2D call. Okay, we'll fix the comment later. All right, so we're going to push stuff on the stack, which is fine. We're going to call increment VPC just past start 2D, yes. And then we're going to start doing the stuff. Okay. All right, so let's step past the two stores. All right, reg read x0. Hey, there's our number, our name, SS1. Okay, so it's at the start of the secondary. That's a good sign. Finally. All right, and then SS1, that's 4150. Let's look back here. 4150. Okay, so that's the pointer to our secondary 1. Yes, that's correct. Okay. We're going to set x20 to 1 past it. Step x20 is 4158. Okay, so that's one word past it. All right. Now okay, x0. I'm a little worried about x0 there. Okay. x0 was the pointer in. We're changing it, but x20 is tracking the real thing. Okay, so now if I load x0 with the contents of that, okay, so we'll step reg read x0, 41A0 is SS2, good, and reg read x20 should be one further. Okay, it was SS plus 8, now it's SS1 plus 16. Okay, so now we have the address of SS2, 41A0, Go back up here. A0. His first step is going to be call SS start to D. Okay. So we want to load X1 with the contents of X0. Okay. Step. Reg read X0. X1. Okay, that is 3D4. That's start 2D. Okay, so we've loaded X1, and now has the address we want to call, and X0 is pointing to the secondary 2. Where'd that go? SS2. So that seems good. We're going to call it now. The gap in my head, X0 is dead at this point because we're saving it. And we come back in, we look at X20, but we don't reuse X0. So, okay, it's a true temp. Okay, so now we're pointing to what? SSX1. X0 is pointing to SS2. X1 is pointing to the routine to run. We're going to call it indirectly. All right. I'm going to step, and that should put me back at start 2D. All right. That looks like start 2D, even though it doesn't mention it by name. Okay. Now, what was that thread? Help thread. Thread backtrace. Huh? Defaults to thread indexes. Oh, that's threads. Now I want trace. No. Shoot. Sorry. What was that? We have down. Goes like that? No. Thread, tray. That's not the command I did before. Trace dump. Oh. No. Okay. Oh. I can go up, I can go down, but I don't know how to see where I am. Frame. Well, ugh. Okay, well, where I believe I am, maybe a quick search will do it. Frame info. Thread backtrace. Okay. Thought I did that. No, that's not enough. Maybe I haven't gone far enough to do it. Okay. Let's step over our two pushes. Okay. Reg read x0 ss2. All right, so we're pointing at the ss2 value. All right, if we step, we've added to it. Okay. And then reg read x20 ss2 plus 8. Okay, so the stack, the virtual program counter is now pointing at the first word inside our thing. So SS2 was pointing to start 2D. This was pointing there. Okay, so let's, we're going to load X0 is push. Okay. Three F58. So X0 is pointing at push. Okay, we'll step. I lost that one. X1 is now, should be the address of something. Oh, what is that? But that's what's giving us our bus error. Oh. Okay, something's gone. 3F58. Somehow we're loading this early. 3F58 should be push. And it is. But before we can do it, we load one more level of indirection. Oh. Okay, now I think we've gone too far, right? Because now we had X1 before this step. Where's the step? Yeah, here we had X0. Well, X0 is still right. We've jumped a level too far though. Because we want to load now. I think I'm wrong on what I want in that thing. I think the secondary has to have the pointer to the dictionary entry or a pointer to the code. So if x1, can we change it? No, debugger setting. Okay. Yeah, that's something different. Right, what's that? Nope. I want to force a value into a register. Can I do that? Whoops. Not a breakpoint, not a watch point. Examining variables. I can't force my own values in? Oh, man. Where'd the variables go? Examining variables. Yeah, we don't have variables in their sense. We just have registers. It's not a breakpoint. I don't know. I can just try, but I got a feeling it won't work. Reg read x0, reg read x1. Can I just say x1 equals this? No. Okay. Oh. Well, I think x0 can. It's not. I think x0 should be pointing to, like for a secondary, x0 should be pointing here. And the first routine in this list is always start 2D. And the last one is always end 2D. So I think our secondary is okay because we actually did jump into our secondary the way we wanted. But I think maybe I'm wrong on these. The code I had, you shouldn't need to load x0 at this point when it points to push. Yeah, but we need that indirection for the primary calls though, because I think, man, I'm getting so tangled. Let's see. Where's my primary and secondary thing again? So normally you would point to this address of code is the word address, and that means you should be pointing to this dictionary entry. You're pointing to this cell containing the address of code, so it's a pointer to code, and that's what I'm doing. It's like I'm messing up what I'm getting to. So for a primary, okay, let me bring this back. If the address has a secondary, then it's a pointer to a secondary pointing to a list of stuff. Where's a picture like that? Well, this one. Okay. Yeah, this is what things should look like. The start 2D routine points to a pointer to the code, or it points to a secondary, which is like this. So it points to something with the first cell as a pointer to the code to run. So I think when I think my fix for the secondaries is actually bad. I should be pointing to that dictionary entry and let it do the indirection. But I'm not quite sure. This. Yeah, okay. The real deal is this has to be the same for primaries and secondaries, and I'm doing something that makes it wrong for that. All right, I'm gonna. What am I gonna do? I think I'm gonna take out what I put in on secondaries. Is what I'm gonna do. This dictionary reference gave us the thing it points to. So in effect, my compile, where'd it go? I think our dictionary routine, so push, did not point here. It actually points to the code, which is wrong because everybody needs to have a pointer to the header, not to the body. Because in the secondary, if you point to the body, you can't execute it, BLR on it or anything like that. So this does seem wrong to me. I'm going back to your original argument. that entry seems wrong. Okay, so if I take this out, what am I doing? I'm writing the address of the dictionary entry into wherever x0 says and post incrementing that. Gosh, that feels right. Okay, I'm going to do this. I'm going to quit. I'm going to make clean because I feel like I've been burned here. Then I got to fix my other thing, but we'll save that. Now I'll do a make. Okay, that's still failing, and let me find my make file. Everybody should depend on these macros. Core tests. Wait, we have core test.macros is not on the list. Okay, that is a problem. Core tests depends on core tests.macros. Unit test demo depends on that. And so does, well, C-like probably doesn't, but interpreter definitely does. Okay. So do a make. All right. Okay. Break. Set minus B. Start 2D. Okay. Run. Mem read minus C 418. Is that right? Whatever number it was. And let's go back to our 4100. Okay. All right, so we're at, where are we? Well, we're at start 2D. We're run, okay. And now this has the right number. That's code, that's code, that's code. I feel good about that. Now this one, 4110, nope, 4100, that's the address of start 2D. That's the address of secondary 2. That's the address of 4110 is N2D. Okay. Start 2D, push that one value N2D. Okay. Well, step and step. Okay. X0 is the value coming in, becomes X20. Reg read X20. Okay. The virtual PC, we're one past our SS1. So SS1, that should be the address of the secondary. Okay. Now if I step, all right, that was X1 is what the secondary points to. All right, step, read X1. Oops, is that right? Oh, it's off. Maybe that was it, but I don't think I want that level of indirection. I mean, because the dictionary entries should act as if the code were right behind them, or right after them. It shouldn't affect it. All right, this gets hard to read these. Interpreter. Okay, so X0, X1 should be contents of X0. X0 points to SS2. How is that possible? X0 got incremented. No, X20 did. Points to SS2. X0 is... Gosh, I'm still not doing it right. X0 points to SS2 because we just did this line. X20, well, let's look at X20 too. X20 is SS1 plus 16. Okay, so we are about to call SS2 is what we want to do. Okay. And then X0 points to SS2. If we load this register, X1 should be, oh, golly. Okay, let's do a mem read. I'm going to see 418, this. Okay, dictionary, S1, S2. Okay, so X1 points to debug data. 4100 is the address of the routine we want to call, is X1. But that's the container for it. Yeah, you may be right, but I feel like that extra indirection just is too far. This should only need 2 if we're doing it right, I think. But I've been plenty wrong all day. Okay, but at this point, X20 is pointing to secondary 1, his call to secondary 2. So we load X0 with that number. That should be the address of SS2 in X0. And I think that's what we said we had. X0 is SS2, right. Okay. Then we're going to load whatever's at there. It's like I need another level. Okay. So X0 I don't know. I know it's 4:30. I'm going to go a couple more minutes, but I won't change code. I'm just trying to think through what's going on here. So X0 points to SS2. That seems right. We need to point to the block as we go into Start 2D. X1 points to the dictionary entry at X0. I think Start 2D needs to be different, is what it is. I think when we're building our secondary, this needs to be the actual address of the code because this is the dictionary entry. All right. I'm gonna make that claim in here. Okay, so lots of debugging. Trying to straighten out the levels of indirection. Okay. And then working theory at this point, secondary needs to store address, needs first word to store address of Start 2D, not its dictionary entry. Other words need to point to the dictionary entry. All right. And we will pick up there. Okay. So, my shower insight was not quite enough to get us through today, but I think this is the last piece that the Start 2D is one back, but we got here okay. I don't know. We'll see tomorrow, but I'm hopeful tomorrow goes a little cleaner. We'll see. All right. Well, thanks for joining. Debugging is kind of a painful process, but I appreciate you being here. So take care, and I'll see you tomorrow or another time. Bye-bye.